Okay, so how do you make a detector that's maybe 100 times better so you can hope to see the moon? Well, there were a couple of things they could look at. One thing you could do is make this shield at the front, this thin screen, even thinner. So a lot of experimentation was done. I think they actually used a mica sheet at the end. That made them somewhat more sensitive. But the main problem was that for every X-ray that came in and generated a pulse of electricity, there were many cosmic rays, protons and electrons moving at high speed, orbiting around the Earth's upper atmosphere, that crashed into this and generated pulses as well. And those were far more common than the X-rays.
Yeah, so we forget that, X-rays are one thing out there, but these cosmic rays caused by the sun, and it turns out from things all around the galaxy, are very common. And ultimately, if you produce an electron, however you do it, whether you're an X-ray or just a high-speed particle, you're going to get the same signal. There's no way to tell the difference on this.
The sun was so bright in X-rays that they'd measure a background level of signal, then they point at the sun, they'd see more.
Yep.
But that was not going to work for these fainter signals like you might get from the moon. They needed some way to get rid of the background. And luckily, the thing is that these cosmic rays, as we call them, as they come through, they might generate an electron here, but they're going to keep going. They go out the back, and what you could do is put another detector at the back, or maybe another detector at the sides and all around the place. Because any cosmic ray that goes through is going to hit this and hit that. It's going to generate a pulse of electricity here and a pulse of electricity behind. And then you have some clever electronics that says, if there's a pulse here and a pulse there at almost the same time, ignore it.
Yep.
But if there's a pulse here and not a pulse there, it's probably an X-ray, and we should pay attention to it.
Right, and that can improve the sensitivity of the detector to X-rays by like a factor of 100 or so, because you're getting rid of all that noise. It's sort of getting rid of the fog of the stuff you don't want.
So they got this working. They were able to have detectors that were about 100 times more sensitive than the first ones. And then they needed to launch it. They launched it on an Aero-B rocket in 1962. They had a little port would open at the side here, and as the thing would move around, it would survey the sky as it span around. And sure enough, they picked up a signal, a really strong signal.
Really big signal. So there's the moon, which they thought they might be able to see, and it looks like maybe they did see it. But there's something way bigger than the moon
It's not
to
quite the
contend
same
with.
place.
Yeah, it's not quite at the same place, and it's much, much brighter than it appears to be that the moon is.
So they picked up a signal, a really strong signal, such a strong signal that the X-rays from the signal, whatever it is, are enough to actually appreciably ionize the upper atmosphere. But it's not coming from the moon. Where is it coming from? Well, they tried to map where it's happening. Here's a map of the sky. And this box is the area, somewhere in this box must be where this X-ray source is coming from.
But there's no bright stars or anything there. There's not really anything there.
It's quite close to the galactic centre, but not very close. It's in the Milky Way. There are maybe 100,000 or a few million visible stars in that area, because the accuracy was very precise. They just knew vaguely this area. They didn't pin down very accurately where it was coming from. But none of the stars looked particularly interesting. So it looked like somehow a fairly normal-looking star, at best, or maybe something quite different that's even fainter than a normal star, was putting out such a huge flux of X-rays it could ionize the upper atmosphere.
Well, you would certainly need something pretty big and pretty hot to do that.
So let's work out how hot you'd need it.